Disasters don't just happen. They're triggered by a chain of critical events. Unravel the fateful decisions in those final seconds from disaster.
Boeing 747. You reach me? Boeing 747. Hello? Boeing 747. DHL. Junior. Boeing 747. Sir, come here, sir. What's wrong, mate? They have been missing one another.
Captain, yes? ATC command us to climb, but Tika showed us to descend. Which one we should follow?
I think we should follow the ATC. Ready?
Assalamualaikum warahmatullahi wabarakatuh. I am Faeez from our group 1. Want to present about the video radar presentation. On the 1st July 2002 at night, Boeing 757 registered by DHL was en route from Italy to the Brussels, Belgium. Has collided with the Tupolev 154 will be registered by British Airlines, also en route for Munich to Barcelona. The collision has been resulting to 71 fatalities, including several children who are on their way to the vacation. Both aircraft have been equipped with TCAS, but how this happened? How the incident happened? What version of TCAS used? The principal operation and the cause of the accident. We shall see in this video presentation.
Hello guys, my name is Hazim bin Rosli, and today we're gonna move to the first question, and which is the system used to reduce the risk of mid-air collision. The system that been used are called Traffic Collision Avoidance System 2 or TCAS 2 version 7.1. Okay, let's move on to the component of the TCAS system. There are 6 main components in the aircraft. The component are the TCAS computer that will perform airspace surveillance, tracking threat detection and give resolution advisory maneuver to the pilot. And then the Mohd S transponder, it will perform as connection of air-to-air data between aircraft that have TCAS system on board. Next, there are also the Mohd S control panel that will allow the pilot to control all the TCAS equipment, Mohd S transponder and TCAS display. Next is antenna. TCAS 2 uses 2 antenna which is on top and bottom of the aircraft. At top, it will use a directional antenna, and at the bottom, it will use omnidirectional or directional antenna. And this antenna will receive the signal of 1030 MHz and reply at 1090 MHz. And then the display that will give a pilot the information of resolution advisory and traffic advisory. And lastly is the speaker that will give aural signal instruction to the pilot, such as climb and descend.
So, we will move to the second question, which is the principal operation of TCAS 2. TCAS 2 provide aural and visual warnings to pilot as well as resolution advisories instructing. For example, one airplane to climb and another one to descend to avoid a mid-air collision. So, here's how TCAS 2 works. The first one is radio interrogation. Aircraft equipped with TCAS send out and receive radio signal several times per second over 2 frequencies. Signal received in the certain frequencies from the transponder abroad. Other aircraft provide constantly changing 3D map of the traffic picture, which allow TCAS to perceive and react to the target threat. At the same time, TCAS send out signal over the certain radio frequency that can be received and interpreted by other nearby TCAS equipped aircraft. So, the second part is resolution advisory. The resolution advisory is what set TCAS 2 apart from the original version of the technology known as TCAS 1. From the 3D map of traffic, it stores and constantly updates its memory. TCAS 2 can instruct a crew to climb or descend in response to a target threat while negotiating with the offending airplane to take the opposite course of action. A protected volume of airspeed surrounds each TCAS 2 equipped aircraft. If an intruder aircraft enters this bubble, the system will provide traffic advisory. If a mid-air collision is likely, an instruction such as climb, or descend will be provided. So, the last part of the principal operation of TCAS 2 is software. The software allows the TCAS to reverse the climb or descent order if it sees a target airplane isn't following the expected trajectory. It can also provide a level of oral alert if that's what makes sense for the given situation, and it monitors terrain and obstacle data to ensure it doesn't command a descent at too low an altitude. It is important to note that for TCAS to function properly, the target airplane must be equipped with an operating transponder.
Okay, we'll move on to the third question. So this is the basic information display of TCAS. So the first thing is the 12 nautical miles shows the selected display range. So the first shape, the hollow dimension, shows other non-traffic. And the negative 20 shows the track is 2000 feet below. So, and then the full dimension, the non-traffic traffic, and it is in close proximity. The negative 10 is shows the negative 1000, means the 1000 feet below. So the dimension sometimes white in color or sometimes is in blue. So the next is the round shape is the traffic advisory. The 00 means it are level with our aircraft. Then the square shape, the resolution advisory. The positive 7 shows the track is 700 feet above, and the arrow shows the aircraft are descending. That's.
Assalamualaikum, I'm Muhammad Faeez, and let's move on to the question 4. Today, we're going to talk about the cause of accident and how we're going to prevent the mid-air collision. There have been 3 factors that have led to the accident. The first is single man operation, and we can call it SMOP. That night, only 2 controllers have been on duty, and at that time, 1 controller on duty and the other one on the brake. This led to the lack of supervision and the assistance in the aircraft situation. This SMOP was controversial procedure implemented in 2001. The next reason is the phone system. As we know, phone system enable the controller to communicate with another when they touch the button. That night, the main telephone was out for the maintenance and the system software also had a failure. As a result, when the controller tried to contact the FAA tower in Germany to inform the collision, it cannot be reached. As a result, the controller can prevent the pilot as the 2 aircraft reach the same route and it collide. The third reason is the TCAS. As we know, TCAS not only for the advisory but also the avoidance. After the pilot has been alert for the collision, the TCAS has instruct the DHL to descend, but the TCAS also instruct the 2.154 to climb. Moreover, the controller instruct the 2.154 to descend also. As we know, TCAS not provided the controller the information regarding the advisory. Due to the miscommunication, the collision cannot be prevented, and this led to the 71 fatalities, including several children. Okay, next is we want to talk about how to reduce the mid-air collision between 2 aircraft that fly near together. My first point is more controllers are needed at night to control the ATC. Okay. The reason is, at night, more controller needed to assess the air traffic because it's hard to detect if there's a critical situation happen. Besides, the controller will have a good backup and a supervision if the aircraft fly near each other. My next point is the TCAS. The pilot should follow the TCAS first if the TCAS instruct them to avoid, because as aircraft can fly near each other. Moreover, the TCAS have been set to make sure that the aircraft route is safe and prevent the collision to happen again. Okay, that's all from me.